So this is meant to be a little bit more supplementary than the other two. Um, this is hopefully I can just go over this stuff slightly quickly, just as a quick review because this has spanned a couple weeks now. Um, First thing in this chapter that we went over was end behavior, and there's a couple of things we need to know, and basically you should memorize, which is degree and leading coefficient. So a quick example, if we have y is equal to negative 5x to the fifth minus 4x to the sixth plus 3, the degree is always going to be the highest exponent. So in this case, the degree is 6. And the leading coefficient is the thing attached to that. So this is negative 4. And these two things tell us the basic end behavior of any graph, right? So degree can be even, and degree can be odd. And within those, there's two categories. Leading coefficient is positive, and leading coefficient is negative. So there are 4 different things we kind of got to memorize on this. When a leading coefficient is positive for an even degree, we'll get something that starts up top, does something in the middle, but always ends up top. So as x approaches negative infinity, f of x, the graph, also, well, approaches positive infinity. And as x approaches positive infinity, f of x also approaches positive infinity. So no matter what way you go on the graph, the graph is always going to go up infinitely high. When the degree is odd and the leading coefficient is positive, we'll have a graph that starts down low, does something in between, and then ends up top. So as x approaches negative infinity, f of x also approaches negative infinity. And as x approaches positive infinity, f of x also approaches positive infinity. So as we go left, the graph goes down. As we go right, the graph goes up. For an even degree and a leading coefficient that's negative, we're just going to get the upside down of this. So it's going to start low, do some stuff in between, and then end low. So x will approach negative infinity both ways. And then for the leading coefficient is negative for an odd degree. Again, we just get the reverse of the thing above it. So it'll start up top, do some stuff in between, and then end on bottom. So as x approaches negative infinity, so as the graph moves left, f of x will approach positive infinity. And as we move right, as x approaches positive infinity, f of x will approach negative infinity. So that's end behavior. We need to be able to get that from finding the degree of the function and then finding the leading coefficient. Again, the degree is the highest exponent of x, and the leading coefficient is the thing attached to that variable. So step one is you have to be able to find those. Besides finding the end behavior of a function, like the most important thing that we can find in anything we do are the zeros. So to find zeros, we always set our equation equal to 0. So if we have some function f of x, let's say it's like 3x cubed plus x squared minus x plus 1, just for example. In order to find the zeros, we set this equal to 0, and then we can do a number of things. The easiest thing to do in this case, this isn't a quadratic, so we can't use the quadratic formula. We can always plug this into our calculator, into y1. So if that entire thing, put it in your y equals, hit graph, hit second trace, and then we want the 0 option. After you hit enter on 0, the calculator is going to ask you a couple questions, left bound, right bound, and then guess. For the left bound, you take your cursor, go to the left of the 0 you're trying to find, hit enter, then it'll ask right bound, take your cursor, go to the right of the 0 you're trying to find, hit enter, and then guess, so go somewhere between those 2 points and hit enter, and then it'll give you the 0. So that is the easiest way to find any 0 ever. If it's quadratic, you can always use the quadratic formula. Yes, it's only for the TI series. But we should know how to use the quadratic formula, we should know how to factor, and we should know how to factor by grouping. So it doesn't necessarily need to be a quadratic in order to factor. And there are examples of that on the homework, which we'll get to in a little bit. Again, this isn't meant to be like super in-depth, at least this first part, because this video has already been made. But we need to keep in mind on how to get zeros of a function. All right, so graphing, factoring, using the quadratic formula, using formulas, those are things that we need to know. And I'm going to assume you know for the test. Once we find those zeros, we can plot them, and then using end behavior and the intermediate value theorem, we can pretty accurately draw a graph. I'm not going to go over that super in depth right now. Again, that video's already been made. If you want to, you can go back and look at that. But this stuff I felt like we were pretty good on, so I'm not going to spend a whole lot of time on it right now. Next thing we did was vertex form. So vertex form is just another form of a quadratic. So you're used to seeing quadratics in something of a form that looks like this. So x squared minus 4x minus 54 equals negative 5. That's standard form, and you will see it mostly in that form. But information isn't quite as easy to get out of that. Instead, we can use vertex form, and that form automatically gives us the vertex without doing any math. All right, so let's take this first example. And I know most of you have probably done this in class, but let's put this into vertex form. And these aren't the right answers. That's finding the zeros, which I'm not asking you to do. But when we're finding vertex form of this function, the first thing I always do is get all the constants on one side so you don't have to worry about it. So I would add over 54. When we do that, we get x squared minus 4x is equal to 49. Then we complete the square. And what this is doing is it's making everything on the left-hand side something that looks like this. So something that looks like vertex form, or at least the first part of vertex form. All right, so in order to complete the square, you take this value, divide it by 2. So in this case, we get negative 2. And then we take that value and square it, which gives us 4. Then we have to add this to both sides of our equation to keep it balanced. So when we do that, we get x squared minus 4x plus 4 is equal to 49 plus 4. If we simplify that, we get x squared minus 4x plus 4 is equal to 53. And then we can factor the left-hand side. So if we factor this, we'll get x minus 2 squared is equal to 53. And then all we have to do is get this 53 back over to the right, to the left. So we get x minus 2 quantity squared minus 53 is equal to 0. Now our vertex is just h and k. So our answer, our vertex, is 2, negative 53. It is positive 2 because it's always the opposite of what's inside. Think back to when we were doing shifts and transformations. When it was inside parentheses, you always did the exact opposite of what you thought. It's the same thing here. So I'll do one more of those just so people can see another example. We'll do number 6. So number 6 says n squared minus 8n minus 69 is equal to negative 4. Again, the first thing we do is add over all the constants to the right. So if we do that, we do n squared minus 8n is equal to 65. Then we take this middle value, we divide it by 2, which gives us negative 4. Then we take that value and square it to get 16. And then we add that value to both sides. So when we do that, we get n squared minus 8n plus 16 is equal to 65 plus 16. When we factor the left, we get n minus 4 quantity squared is equal to 81. When we add, or when we subtract 81 to both sides, we get n minus 4 quantity squared minus 81 is equal to 0. So our vertex is 4, negative 81. The next thing we did was division of polynomials. So an example I gave you on that review packet, this is number 11. So we want to divide this entire thing by 4x minus 1. So in order to do this using long division, we do 4x minus 1, and then put 28x cubed minus 19x squared plus 19x minus 14. The first thing you have to do, which shouldn't really be a problem, is to make sure that these powers of x are in order. So this goes x cubed, x squared, x, and constant, so we're all good. Then we're constantly asking ourselves what goes into the farthest left value. So you should be asking yourselves, how many times does 4x go into 28x cubed? And the answer to that would be 7x squared. When you multiply 7x squared by 4x minus 1, you get 28x cubed minus 7x squared. And then we're subtracting. When we do that, 28x cubed minus 28x cubed gives you 0. Negative 19x squared minus a negative 7x squared gives you negative 12x squared. And then you gotta bring down the next value. And then we just rinse and repeat. So then we're asking ourselves, how many times does 4x go into negative 12x cubed? Answer to that would be negative 3x. When you multiply negative 3x by 4x minus 1, you get negative 12x squared plus 3x. Then we subtract those things. So negative 12x squared minus negative 12x squared gives us 0, and 19x minus 3x gives us 16x. Then we bring down the next value. And again, just rinse and repeat that. So 4x goes into 16x 4 times. When we multiply 4 by 4x minus 1, we get 16x minus 4. Subtract that. 16x minus 16x gives us 0. Negative 14 minus a negative 4 gives us 10, negative 10. And then because there's no other values to bring down, that's our remainder. So our answer is 7x squared minus 3x plus 4 minus 10 over 4x minus 1. Yeah, so it should always go in decreasing degree order. So if you didn't have, so say this was 28x cubed plus 19x minus 14, you would still have to put a placeholder for negative 19x squared. Think of it as zeros in actual division. But yes, you are right. Next thing is synthetic division. Synthetic kind of works the same way. It just requires a little bit less thought. The first thing you do with synthetic division is you set whatever you're dividing equal to 0. So n minus 3 equals 0. So n is equal to 3. That goes on the outside of our box. And everything on the inside of the box we put in just with coefficients. So coefficient of n cubed is 1. Then it would be negative 7, positive 16, and then minus 5. First thing you do is bring down this first value, and then you multiply 3 by everything that ends up down here. So 3 times 1 is 3, and we want to add down. So negative 7 plus 3 is negative 4. 3 times negative 4 is negative 12. 16 plus a negative 12 is 4. 3 times 4 is 12. Negative 5 plus 12 is 7. So this last value will always be your remainder, and your answer will have these as coefficients. In this case, our answer is n squared minus 4n plus 4, and then plus 7 over n minus 3. Next thing that we really need to know are imaginary numbers. Before we get to imaginary numbers, I want to just review radicals in general. So say in the general case, you have a product of two things, a and b, under a square root. You can separate that into the square root of a times the square root of b. Alright, so let's say you have the square root of 125. We can split that up into the square root of 25 times the square root of 5. And when we do that and simplify, Square root of 25 is 5. Square root of 5, there's no perfect square factors, so that just stays as is. So our answer is 5 root 5. So when we're simplifying radicals, we're really trying to take out perfect square factors and then simplify from that. Now, in order to have a rational fraction, there can be no radicals in the denominator. So let's say you have something like 1 over square root of 3, and we want to rationalize that. In order to rationalize that, you have to multiply by the denominator over itself. So we would multiply 1 over root 3 times root 3 over root 3. When we do that, we get root 3 over root 3 times root 3, which just simplifies to 3. If we have something a little bit more complicated, let's say 1 over 3 plus square root of 2. Square root of 2. In order to rationalize this, we need to multiply by the conjugate of the denominator. So the conjugate is basically the same thing, except we change the middle sign. So we'd multiply by 3 minus root 2 over 3 minus root 2. When we do that, we get 3 minus root 2 on top. And then when we FOIL, we get 9 minus 3 root 2 plus 3 root 2 minus root 2 times root 2, which is just 2. Which if we simplify, these middle terms cancel. So we get 3 minus root 2 over 9 minus 2, which is 7. And then this is a rational answer. Not a rational number, but a rational answer. Where this gets different, not necessarily harder, is when we start to get things that look like negative, the square root of negative 125. And if you just go back to the definition of what a square root actually is asking, you know that there can be no negatives under a square root, because nothing times itself can be negative. But what we can do, if we use the rules above, we can separate this into different factors. So we can separate this as square root of negative 1 times the square root of 25 times the square root of 5. Now, the square root of negative 1 will always be equal to I. That is the designation for the square root of negative 1. Those mean the same thing. And then everything else is really the same. So the square root of 25 is 5, and the square root of 5 stays still. So our answer is 5i root 5. And then again, if we had something a little bit more difficult, let's say 1 over 4i. In order to undo that, you can multiply by the denominator over itself. And really, you can multiply by something a little bit more simple. You can multiply by just I over itself. Because when we do this, we get I over 4i squared, which simplifies to I over 4 times negative 1. Because I squared is always negative 1, which will just equal negative I over 4. Not a real answer, but it's rational. And I also acts as any variable would. So when you're adding and subtracting it, it works the same way. So for example, in number 19, it asks negative 7 minus 2i minus negative 2 minus 2i. Because we're not multiplying, we're just combining like terms. So what this says is -7 minus -2, which is really -7 plus 2, which is -5. And then -2i minus a -2i, which if we have -2 of something and we add 2 of something, we just get 0. So this just simplifies to -5. Again, in this case, just treat I as a variable and everything will work out. We can also multiply things. So in number 20, we have 8 minus 8i times -5 plus 7i. Again, treat those i's as variables and everything works the same way until the very last step where we have to simplify just a little bit. So if we FOIL like normal, 8 times -5 is -40. 8 times 7i is 56i. -8i times -5 is positive 40i. And then -8i times 7i is -56i squared. So then we have to combine like terms and simplify. So -40 plus 96i minus 56 times -1. Again, because I squared is equal to -1. So then we have -40 plus 56 plus 96i, which is equal to 16 plus 96i. I showed more steps than you need to, but I'm just showing you exactly what's happening. The same holds true for rationalizing fractions. So number 30, which is probably a little bit longer, that says to rationalize -1 minus 6i over -8 minus 4i. So just like the radicals up above, we have to multiply by the conjugate of the denominator. So the conjugate of the denominator, again, is the same thing here, except we change the middle sign. So we need to multiply by -8 plus 4i over -8 plus 4i. And then we have to FOIL all of that. When we do that, up top, -1 times -8 is 8. -1 times 4i is a -4i. -6i times -8 is 48i. And then -6i times 4i is a -24i squared. This is just one note. It's nothing special. When we FOIL on bottom, we get -8 times -8, which is 64. -8 times 4i is -32i. -4i times -8 is positive 32i. And then -4i times 4i is -16i squared. Then we have to do a bunch of simplifying. So when we simplify the top, we get 8 plus 44i plus 24, because -24i squared is really -24 times -1. And then on the bottom, the middle terms cancel, and we get 64 plus 16. Again, because negative 16i squared is really just positive 16. So then we just have to simplify one more step. 8 plus 24 is 32. And then 64 plus 16 is 80. So that's an acceptable answer. So really, for imaginary numbers, so long as you know how to do everything under square roots and rationalizing everything with square roots, you can do imaginary numbers. The main thing to know is that square root of negative 1 is I, and I squared is negative 1. Square root of negative 1 times square root of negative 1, which again is just negative 1. If you can remember those two things, and the normal rules with rationals or radicals, this should be really, really easy. So the next kind of biggest thing, which will probably be a major part of the test, are asymptotes. Right now I'm just going to write down the rules first, and then we'll have a couple of examples with them. Again, all the examples are in on campus. I'll rewrite them, but that's what we'll be doing. So just give me a second to write them down, and then we'll go over it. All right. So quickly, I'm just going to run over these rules. Um, if we have a function, which we're just going to split up into our numerator function and our denominator function, there are asymptotes in different cases. So vertical asymptotes happen when our denominator is 0. Reason being is because we cannot divide by 0. 4 divided by 0 is an undefined value, right? We can't divide anything by 0. So if you set the denominator equal to 0, whatever values you get, those are vertical asymptotes. And horizontal asymptotes depend almost solely on the degree of the numerator and denominator. So all we're doing for horizontal asymptotes are comparing the degree of the numerator and the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, I'm on the first one, then y is equal to 0 is the horizontal asymptote. That horizontal line, y equals 0, that's the line we shouldn't cross, or at least most times. Okay. If the degrees are equal, you take the ratio of the leading coefficients. If the degree of the numerator is greater than the degree of the denominator, there's generally no horizontal asymptote. But, and this is a special case with slant, if the degree of the numerator is exactly 1 degree greater than the degree of the denominator, then there's a slant asymptote. And we find that by doing long division, we actually carrying out the division of the problem. So, for example, this is number 40 on that review packet. So the first thing we can do is we can set our denominator equal to 0 to find vertical asymptotes. So negative 2x squared minus 4x plus 6 is equal to 0. I'm going to choose to factor this. If it's not a quadratic, it's a cubic or a quartic or anything higher than that, you can use your calculator. You can graph it, second trace, zeros, go from there, right? Probably going to be decently simple for the test, but I'm going to factor it. First thing I'm going to do is take a negative 2 out. When we do that, we get x squared plus 2x minus 3. And then we need to factor x squared plus 2x minus 3. So we need factors of negative 3 that add up to positive 2, which should be x plus 3 and x minus 1. So just checking, we get x squared minus x plus 3x minus 3, so that works. So to solve for this, negative 2 can't equal 0, So we have to set x plus 3 equal to 0 and x minus 1 equal to 0. And when we do that, we get x is equal to negative 3 and x is equal to 1. So these two things are our vertical asymptotes. The horizontal asymptotes are determined by comparing the degree of the numerator and the degree of the denominator. So degree is 2 in the numerator, and it's also 2 in denominator. These are equal to each other. So our horizontal asymptote is the ratio of the leading coefficient of the numerator over the leading coefficient of the denominator. So it's 1 over negative 2. Okay, so we found all the asymptotes. Then we got to start graphing it. All right, so once we graph those asymptotes, then we can figure out what's happening to the left of them, between them, and to the right of them. In order to do that, we want values to the left of the leftmost asymptote. So we'll pick negative 4. We want a value in between the two asymptotes, so we'll pick 0. And we're also going to pick negative 2, just to make sure it doesn't actually cross this blue line. And then we're going to take an asymptote to the right of the red line. So we're going to take positive 2. So the next thing we do is we just evaluate those numbers of x. So we get f of negative 4, f of negative 2, f of 0, and f of 2. And I don't have a calculator on me, so this is going to take a second. So when we plug in -4, -2, 0, and 2, for -4, everything in the numerator just becomes 0. So that value is 0. All right. Because 0 is greater than the blue line, so 0 is greater than -1/2, the graph to the left of this red asymptote will always be above. So it'll look something like that. Okay. -2 and 0 both give us values that are below the blue line. All right, so if we plug in -2 for x, we get -2 out as our output, which is below the blue line. So -2 is less than 0. When we plug in 0, we also get -2 point something, which is also less than 0. So both of those values are below the blue line. So everything in this little sector will also be below the blue line. So our graph will look something like this. Then when we plug in 2, we get -12 over -10, which simplifies to just 12 over 10, which is positive. So 12 over 10 is greater than -1/2. And these two middle values should read -1/2, because that's the blue line. Now, because 12/10 is greater than -1/2, our graph is going to be above the blue line and to the right. So our graph will look like what we have in pink. Now, that's a lot of work, and that's a lot of memorization. But it's so long as we remember these rules, everything else is simple. So if we know how to use our calculator and memorize those rules, everything should be pretty easy. It just takes a little bit of time. So as another example, we'll do number 46. So again, set the denominator equal to 0. You can do that one of two ways. You can factor it. Or you can use algebra. I'm going to factor it because it gets both values very easily. So x squared minus 4 factors to x plus 2 times x minus 2. When we set both those equal to 0, we get x is -2 and x is +2. Then we compare the 2 degrees. Both are 2 in this case, so we have the ratio of the leading coefficients, which both are 1. So our horizontal asymptote will be 1 over 1, which is just 1. once we graph our asymptotes, so -2, 2, and y equals 1, then we need to see what happens outside of the bounds of those asymptotes. So first, let's see what happens to the left of the leftmost asymptote. So let's plug in -3. So when we do that, we get 12/5, which is greater than 1, which means our graph will be above the blue line and to the left of the red line. Then we're going to plug in a couple values in between. So let's plug in -1 and +1. So in this middle section, when we plug in things between the two asymptotes, we get 0 when we plug in -1, which is less than our blue line. But then, when we plug in 1, we get 4/3, which is greater than our blue line. So what happens is it starts down here, it will cross our blue line, and then it'll go up to infinity. So it'll look a little bit like a cubic. So it is possible to cross the horizontal asymptotes. So usually it happens in between, and you just have to check a couple of values close to the asymptotes to determine that. So then we take a value to the right. So we'll take 3. And evaluate that. When we plug in 3, we get 0, which is less than our blue line. So our graph will be below and to the right. So look a little bit something like that. Again, I realize this takes a little bit of memorization and a little bit of time, but it should not be difficult. So long as you follow the rules in red, blue, and green, everything else will be easy. Okay, so I want to do one more of these, but with a slant asymptote. I'm just going to go over this last one, and then if anyone has any questions, which I doubt there will be because there's only 2 people on, that'll be it. But for number 42, same thing is true. Set that denominator equal to 0. When you do that, you get x equal to -2 and x equals +2. Then, for horizontal asymptote, you compare this 3 with this 2. Because the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Okay? But n is exactly 1 greater than m. So then we have a slant. So then we need to find that. In order to do that, we carry out long division. Okay, so then we ask ourselves how many times 2x squared go into x cubed. That would be 1/2 x. Because 1/2 x times 2x squared would give you x cubed. So then we get x cubed minus 4x. We subtract. When we do that, we get 0, and then -16x plus 4x is 12x. And then that's our remainder. But our remainder doesn't matter. 1/2 x then is our slant. So everything but the remainder is the slant. So then we get to graph our asymptotes. So we get to graph x equals -2, x equals +2, and then y is equal to 1/2 x. Once we do that, we do the same thing as we did before. So we go to the left, we go a couple in between, and then we go to the right. So let's plug in f of -3, f of -1, f of 1, and f of 3. So after we get these values, then we're comparing it to the green line. So if we plug in -3 over here, we get 21/10, which this is, wait 1 second. Yeah, okay. So when we get 21/10, this is greater than 1/2 times -3. So our graph for this portion will be top left. So it'll look something like this. Then in between, we plugged in -1 and 1. When we plug in -1, we get -15/6, which is definitely lower than our green line. So it'll definitely start down here. And when we plug in 1, we get 15/6, which again is more than 1/2. So it'll end up here. So again, it'll kind of look like a cubic. Then when we plug in 3, we get -21/10. This is less than our green value because it is less than 3/2. So when we do that, our graph will look something like this. Okay, and then that's our graph. This is a little different because again, there's a slant and it's crossing. You just plug in different values in between and it'll give you that answer. You just gotta pay attention. So again, if you know those rules and you follow those directions step by step, this really shouldn't be that hard. Just take it really slow, take it step by step, and you'll get credit. All right. So that's really all I'm going to test you on. And I know I spent a lot of time on the asymptote part, but imaginary numbers, radicals, and behavior will all be fair game on that test. And this will be up. It'll be up forever, really. But if you have any questions, email me, and I'll be happy to answer them. I will be doing another one of these specifically for the practice test, so there will be a lot more specific questions. But if we're able to get all of these skills, you're doing really, really well. If you don't know them quite yet, we've got until Friday for that test. Okay, but that's all there is. So I'll leave this open for a couple minutes. If you guys have any questions, just feel free to ask them in the chat, and I'll do my best to answer them. Kevin, I know that you're not in this class, but I'll answer it just for you. All right. I'll call it there. Again, if you have any questions, just email me, and I can answer them as best I can over email or Tuesday during class or Wednesday.